Hi guys, welcome back to another number sense video. Today we're going to talk about multiplication and division. So to first understand multiplication and division, you have to understand the properties. And to do that, I listed out these three right here. Now you probably already know associativity and commutativity from addition. So I would like to talk about inverses first. We think of inverse as kind of the opposite of a number, but to really understand what an inverse means, we have to know what an identity is. An identity is kind of like a number that does nothing. When we think about an operation, for example addition, we have an identity, and that identity is 0. It's 0 because 0 plus anything is just that same number. For example, like 3 plus 0 is still 3. 0 does nothing when we add it. And that's why the additive identity is 0. Now we have something similar for multiplication. I'm sure you guys are thinking it. The multiplicative identity is the number such that when you multiply a number by it, it also does nothing. It's 1. Anything times 1 is just itself. For example, 67 times 1 is just 67 again. Now, of course, when we think about an inverse is an opposite, right? But an opposite, like how? Well, in addition, the inverse is like the negative version of that number. For example, the additive inverse of 2 is negative 2. And it's like this because, in addition, 2 plus negative 2 is 0. We call two numbers inverses if when you do that operation to the two of them, they give the identity. So that means the multiplicative inverse of a number is the number such that when you multiply those two numbers together, you get the multiplicative identity, which is 1. So for example, the multiplicative inverse of 4 is 1/4. And that's because when you multiply 4 and 1/4, you get just 1 back. And let's do another one. The multiplicative inverse of 6/7 is 7/6. Because when you multiply these two, the tops and bottoms will cancel out and you'll just get 1 again. And again, the multiplicative inverse of, for example, negative 3 is negative 1/3. Because when you multiply these two, 3 times 1/3 is just 1, and the negatives will cancel out to make a positive. So negative 3 times negative 1/3 is also 1. These are multiplicative inverses. Now, these are also known as reciprocals. We have a special name for multiplicative inverses, especially because they are pretty important. And you will see them called most likely both names on number sense tests. Multiplicative inverse and reciprocal. So it's important that you know that they are the same thing. Now, I talk about reciprocals first because they actually relate to division. The definition of division is multiplying a number by the reciprocal of another number. I'll show you what I mean. For example, 6 divided by 2. Everyone knows that 6 divided by 2 is 3 because with 6, you can make 3 groups of 2. You're splitting 6 up into groups of 2. But what this is actually saying is 6 times the multiplicative inverse of 2, which is 1/2, which is also equal to 3. And so you can see you'll get the same answer no matter how you think about it, but this is a much more mathematically rigorous way that will also help us when we do these problems over here. Because when we define division to be actually just multiplication in a different form, which this is how we actually define division, it really plays nicely with these other properties, associativity and commutativity. I'll show you something for example. So just review, associativity is kind of like the regrouping property. It says that A times B times C equals A times B times C. So it's essentially saying you could multiply this first or you can multiply this first and they're going to get you the same answer. Now the commutative property is A times B equals B times A. It's just saying you can just multiply the two numbers in whatever order you want. And so these two together say that you can kind of reorder multiplication however you want. And when we combine it with this, which says that division is actually just multiplication, these say you can reorder multiplication and division in whatever order you want. And we'll see that in these problems. Future Aaron here. It's worth noting that when I say these properties allow us to swap around the numbers in multiplication and division, I don't mean that you can just swap around the numbers without changing how the operations move with them. Here's an example. 6 times 5 divided by 2. The reason that I say we're allowed to interchange the numbers is because division is actually multiplication. As you can see here, I'm using this divided by 2, I'm changing it into a times 1/2, and then I can use associativity and commutativity here. But the important thing is that division is actually not commutative. For example, 2 divided by 3 is not the same thing as 3 divided by 2. So we have to be careful when we are moving these numbers around. And remember that essentially the operation moves with the number. So here, the divided by 2 moves with the 2. So you can see this divided by 2, divided by 2. You cannot just change this around. So just swap the 2 and 5. You can't do that like this, because that would be then multiplying by 2 and then dividing by 5, and you're actually changing what's going on. Here you're still dividing by 2 and multiplying by 5 at the end. I hope that clears things up. For example, 5 times 89 times 2. Now you might be tempted to just do this in order and you would get something that's not very nice. But we can notice something. We could reorder this however we wanted, and there's a way to do this that makes the question very convenient. We could do 5 times 2 first, which is 10, of course. And then we're left with just 10 times 89. And multiplying any number by 10 is really, really easy. We just add a 0 to the end. It's going to be a similar idea with this problem, just a little bit more complicated. So you can take a little bit to figure it out if you'd like. Pause the video. Alright, so this question, similar idea. We see 4, 2, 25, and 5. That's a dead giveaway that we should be regrouping our numbers to multiply easier. And here we can say, we can group 4 and 25, and we can group 2 and 5. And you'll see why I do this specifically in a moment. And then we'll just put on the 89 at the end because it was in the problem. 4 times 25 is 100. 2 times 5 is 10. So what we have is 100 times 10 times 89. And this is really easy. This is just 1,000. So we just have 1,000 times 89. Again, multiplying any number by like 1,000 is really easy. Just add 3 zeros to the end. So the answer is 89,000. Now, this was reordering multiplication, but remember what I said, you can also reorder division. So, for example, this question, 28 times 6 divided by 7, we might, again, be tempted to do this first and then divide the entire thing by 7, but that's needlessly complicated, and especially in number sense, when you're doing this mental math, you want to avoid, like, multiplying bigger numbers. So what we can do instead is say this is 28 divided by 7 times 6, and this is really nice because 28 is a multiple of 7. So 28 divided by 7 is just 4. And then 4 times 6, everyone knows, is just 24. This next question is a pretty similar idea. You can pause if you'd like to take a try. Alright, it's a pretty similar idea with this question. We're just going to reorder the multiplication and division again. Because we noticed that 66 is divisible by 6. So we can just say this is equal to 66 first divided by 6 and then times 7. And this is just 11 times 7, which is 77. Now this is going to be a little bit different. Here, in these questions, we're going to use the distributive property, which I did talk about in a previous video, but just as a refresher, the distributive property says that A times B plus C equals AB plus AC. And actually, I should put this as a double arrow here because it's very, very useful to use this property both ways. So here, we're going to be using it in this direction, going from AB plus AC to A times B plus C. For example, here, 99 times 99 plus 99, we can say this is actually like 99 times 1, just mentally, and this is actually just then 99 times 99 plus 1, which is 99 times 100, which is simply 9900. And if you don't want to do this trickery in your head, you can kind of just think of it as, okay, I have 99 99s, and I'm adding one more 99, so in total I have 100 99s, which is just 99 times 100, 9900, or 9900. Similar idea for this one, you can pause to take a try if you'd like. So again, we are going to use the distributive property, and we're going to factor out a 99. So here, we can think of it as 99, 99, and 99. They're all here. If you like it a little bit more orderly, you could reorder this to be 99 times 97, so all these 99s are in front, but it works the same either way. So this is 99 times 98 minus 97, minus, again, this is 99 times 1, so we're going to put a 1. 98 minus 97 minus 1 is just 0. 99 times 0. Anything times 0 is just 0, so our answer is 0. And again, if you don't really want to do this in your head, you can always just think of it as I have 98 99s, then I subtract 97 99s. 98 minus 97 is 199, so I'm left with 199, and then I subtract 99. 199 minus 199 is 0 99s. I have 0, I have nothing. So these are the very basic multiplication and division tricks, just using our basic properties of multiplication and division. These will eventually progress into much more complicated tricks. It's really important that you are well versed in these properties so the next ones also go smoothly. I'll post some practice problems in the comments below. Thank you guys for watching.